Hello friends, welcome to another session on operating systems. So now let us see what a virtual machine is. It's a very well-known term, quite oftenly used virtual machine. So let's see what a virtual machine is. A virtual machine is a software-based emulation of a physical computer. It runs an entire operating system as if it is a real one standalone machine, but it runs inside another system. So on the hardware there is operating system, and inside this operating system another operating system will be working. So for the user thinks that the operating system on which the user is working is directly interacting with the machine, but in turn the operating system on which the user is working may not be directly interacting with the machine, but in between there may be another operating system which is guiding this operating system to interact with the machine. So the whole thing is virtually one machine is available on for each user. So user may be thinking that is working on one type of operating system, but on the reality there may be another operating system installed on the hardware, and the other way the user may be thinking that is working on Intel machine, but in fact it may be a Mac machine working at the back end. We don't know what exactly it is, but the user feels that he is working with his or her own operating system or his or her own hardware. So that's how virtual look is created, as if a real system is available to each user and all that. So why do we require a virtual machine? So it helps us to work with multiple operating systems on one physical machine. That means we can have more than one operating system working simultaneously on the same hardware, and different users may be working with different operating systems simultaneously on the same user, of course through scheduling and all that, but the same hardware is available for multiple users through multiple operating systems and all. So this virtual machine provides an opportunity to have the user feel that they have their own machine, though the same machine is being used for multiple users, and each one is working on their own environment. So it will be easier for testing the software or viruses without affecting the host, because we have our own operating system working, which is limited only to the user, but the machine works with another operating system, and this interaction among the operating systems is through the system calls and all. So it's a highly dedicated one, and they are working in privileged mode, so lot of safety can be provided because of virtual machine concept. Then it is going to save the cost, because we don't require multiple physical servers. So we can have a single physical server and can make it to work. Then we can simulate hardware and environments like IoT and other things. The benefits: we can provide isolation to the various users, we can allow resource sharing, and will be a best way of testing the software and all that without disturbing. So this figure clarifies all the doubts we still have in our mind. So we have a hardware at the bottom, then we have one operating system which is driving the hardware, and on the operating system we have an hypervisor on which we have various uh, virtual machines. Each virtual machine may be having their own operating system. So in all, what we can have is the hardware may be of one type, and that it may be working on some operating system, maybe Linux. On the Linux, one guest may be working on Windows, another may be working on Unix, another may be working on Mac, and so it is possible to have each user work with a different operating system, and that is possible only through what we call virtual machine. So gives a lot of freedom to the users, so don't have to get bound to the what actually physically available and all that. So that's advantage of working with the virtual machines. Now looking at types of the virtual machines, we have basically two types of virtual machines. One what we call a system virtual machine. The examples used were VMware and VirtualBox and all that. This emulates a complete hardware environment to run a full operating system, and provides a platform to install and run an entire operating system, which we call a guest operating system, just we have seen in the previous example. So we have a hardware, on that we have a operating system, on that we can have each guest can have a separate operating system. So we can install the entire operating system on top of the operating system which is directly attached to the hardware, and then it simulates all the physical hardware like CPU, RAM, disk, and all networks are simulated. So each user through the guest operating system feels that all the hardware is fully available, independently available to the user himself or herself, will not allow the user to think that it is being shared or it's all working in some other environment. And also we feel that we are at our own environment. So homely environment is created for each user, independent user, though each user may be comfortable with different environments. Therefore through this system virtual machines, we can provide each user to install their own guest operating systems and work on that, and through this each user feels that the user has access to the CPU, RAM, and all the resources, and it uses a hypervisor to manage the VM life cycle. So we have a single hardware, therefore anytime one of the users will be active, others have to be made inactive, so it has to be somehow scheduled and all that. So that all scheduling and all activities are taken care by the hypervisor shown in the figure. Then we have another type of virtual machine, which is process virtual machine, which is commonly used in Java virtual machines, where it is designed to run a single program or a process in a platform independent way. That means we don't bother about what platform we are working on. So especially when we are creating a Java process, so it doesn't really require what platform we are working on. So it just creates a code that is independent of the platform. That means the platform may be any type of operating system, or it may be any hardware. So independent of the hardware, independent of the software, it is created and this is created when a process starts, and when the process ends it will be destroyed. So this virtual machine is attached with the process. So a virtual machine comes when a process comes to exist, and as long as the process is existing, this virtual machine will be existing. The moment the process is no more existing, this process virtual machine also gets killed. Whereas on the system virtual machine we have created for each user one uh, whole system is virtual machine is created, so that user can create any number of processes on that virtual machine. But here a user independently creates one virtual machine for each process, and it provides an abstraction over the host operating system or CPU architecture, and also just an abstraction it provides, and doesn't emulate any full hardware, and just enough whatever is required for the process, only that part will be simulated. So that's the advantage of working with this. So when we are working with the process VM, then whatever resources are required, only the required resources are emulated and simulated, and a copy of that is available to the process. And through the scheduling, here different processes are being scheduled under each user. So in this case the user may create multiple processes, and the scheduler takes care of the user wise scheduling, and once the user gets a chance to work with, then under that user how many processes are available, they will be scheduled. But here it's directly a process is getting scheduled. So looking at another way, the system virtual machine, we have the virtual machine above which we have an operating system for each application. For each user will have their own operating system. So that's ISA, and we have ABI. We just look at what these are. But in case of process virtual machine, only application is there under ISA, whereas virtual machine operating system are part of the ABI. What is ISA? ISA is instruction set architecture. So how the software tells the hardware what to do. So it's a instruction set. So if you are working with any programming language, then the programming language has its own instruction set. Then the program is written in that using the instruction set of the programming language. So directly in that language instruction set are used and try to inform the hardware, and it is working on its own operating system, and then gets in onto the virtual machine, that is a system virtual machine. Whereas in case of process virtual machine, only the application part is there in the instruction set. That means the user program is only available in the instruction set, whereas other things go into ABI. ABI is the application binary interface, which tells how the compiled programs interact with the system at binary level. So here at the system VM, what happens is the compiled program of any application is interacting with its own operating system defined for the user, and that operating system is interacting with the virtual machine. Whereas in the process virtual machine, the compiled version of the operating system or the compiled version of the program itself is interacting with the virtual machine, and virtual machine in turn interacts with the operating system, which further interacts with the hardware. So looking in more detailed way, the system virtual machine, we have hardware at the bottom, then we have virtualization software, and then we have its own operating system for users own operating system and users applications. So some of the applications the user is using may require this operating system, or some of the applications directly interact with the virtualizing software and get to the hardware. That means virtualizing software is actually the operating system plus the one which is used to create a virtual environment. So the application may directly work on the operating system which is being used for the system, or the application may have their own operating system. So the user may want to work with the operating system which is different from the operating system which is working in the system. So if it is doing so, we have another one path. So application to the local operating system, then global operating system, and then to hardware. Or the application wants to use the global operating system directly, then they can directly use the global operating system and interact with the hardware. So the logical level, if you look at it, the applications either go through their own operating system, local operating system, and get into the virtual world, or the applications can directly get into the virtual world if it is a system virtual machine. But in case of process virtual machine, application itself having a virtualizing software, so application interacts with the virtualizing software. So if that application requires a separate if software, then it goes into the software installed on the hardware, and via that it goes. Or if it wants to work with some other operating system, then the virtualizing software will provide that other operating system. And then so depending on the application, if the application is written on the environment in which the whole system is running, then directly through OS it goes. Or if it is working on some other operating system, then via virtualizing software it goes directly to the hardware without getting into the global operating system. That means the virtual world is the whole thing just below the application process. Whatever is there, everything becomes virtual. Now the process itself gets into the virtual world. So each process gets a virtual world, whereas here each user gets a virtual world, and under each user can have multiple processes. So the scheduling is done in case of system virtual machine in terms of users, whereas in terms of process virtual machine the scheduling is done in terms of process itself. So that's about the virtual machine. Then the virtual machine has created wonders in making big dreams realizable. So we can provide multi-user, multitasking, multiple operating system environment, multi-environment, all things possible only because of this virtual machine concept. So that's it for now. So please do like the videos, and if you find the videos are of any use, please do subscribe and hit the bell icon, and please tell your friends to follow the channel. Many issues to be discussed, many things to be on the queue, so please keep waiting. And that's it for now. Thank you.